All right, good. So I hope you have revised the three important building blocks for creating larger data frames based on smaller data frames. And then we will be able to expand our ability to handle huge sets of data by collecting different sources of smaller data sets. Right? So that is making us much more powerful in terms of being able to handle any kind of data sources, be they sprinkle a lot over a huge number of files, different networks, different servers, different mobile phones, and then we will still be able to very expeditiously integrate them using Panda's powerful .concat, .merge, and .join. So let's come over and join me in the lab where we are now able to try something out. Okay, let's create a new workspace here. And what I'm going to do is to quickly copy over the creation of two data frames from the slide. And of course, we need to import pandas as PD, import numpy as p. Okay. So just running these commands quickly, we get BD and also CD. Yeah, so we are quite familiar with these two data frames by now, having seen them a couple of times. Now let's try out the four different ways to do concat, okay? Which is basically just concatenate them. Axis is 0 by definition. I remember a 0, just plonk it below row wise. Huh? Okay, so I can recall because I've been talking about it, using it. But if I didn't use it for a week or two, it starts to feel a little not uneasy and not sure about what it means. Then I will look up the documentation. And it's fine, no problem, right? Just feel free to search the documentation. Then we have, if you don't specify dot join, is outer join. Why? Remember the data preservation principle, that is union, taking everything in is safer than intersection where you may throw away everything because there's no commonality. So the default for join is outer join, take in everything, union everything. Then we try the join is inner, and then we try join is outer because that's by default, but column wise, axis equals 1, right? And then we finally do the both to both. Then join is inner, axis is 1. And then we will be able to print them all out. So let's try to print them all out using a print. So what we do is print. So we'll see this line first, then df1, then df2, df3, and df, where is my df1, 2? Also, we got df1. Then we have df3, 3i, 4, 4i, then a separator. So let's see what this does. Okay, so not surprisingly, we get to see df3 here, which was basically what we saw earlier on with the outer join. All right, and then the skinny inner join, and it's always skinnier than outer join, or no fatter than the outer join because it's intersection, right? So if we recall, that's here and here, okay? And then we have our df4 and df4i, which is having nan here and then no nans for df4i. And let's see, yeah, so nans here and no nans. Okay, so that's indeed what we were expecting, and we have already micro and analyzed it just now. So if we have understood that, uh, then this part is quite straightforward. Okay, next, let's try our hands on creating or using merge. Okay, so first thing first, let's just make sure we have our df1 and df2. Okay, it's the same thing, just copy again. Then we have, we can try to copy and paste to create our DF3. All right, and let me just enter return here, okay, just to have an easier presentation rather than one long line. So df1 dot merge with df2, left on, right, remember? And then how is inner, how is inner. How is outer means union, and then we print out, and then df3 merge, okay, on D column, both sides must have D defined, otherwise it'll be an error. And the how is based on inner, that means intersection. And then df3 merge, merge is a column-based operations. Therefore, the columns need to be unique. If it's a row-based operations, then the row indexes have to be unique. So how outer? So we are now like fanning out and see all combinations. Okay, so let's run. And let's see what we get. So 3 merge inner, right? So we get the disambiguating auto adjustment of the labels because the D and the D clash, right? And the values are basically what we expect. So if we flip back to our PowerPoint slides, our classroom slides, the merge on inner, yeah, and the merge on outer, we're having some nans there, basically are what we are expecting here. Then we have our on, that means basically it's left on the same label as right on the same label. So no big deal, it's just an easier way to say on the same label value, column label value. We get inner intersection, intersection of the columns. So D is the commonality, and we get this here, and then we list out, right? And then we get outer, that means take the union, so all values of the rows are there. No, all values of the D columns in the data of the data of the D columns are listed. So dot merge looks at the data. This is what we. So the classroom label will have this as the outcome, and it's exactly what we were expecting.